Okay, this is the geometry test review for Chapter 4, covering sections 5, 6, and 7. Again, for a good comprehensive review, you should watch both videos. There it is. Alright, so first one. We're going to complete the statement and explain why it's true. And the most important thing here is the explain part, right? So in the picture, we have ut congruent to what? Congruent to yx. And I believe they throw the yx in because, look, ut... Oh, never mind, sorry. So, what is ut congruent to? Well, if you look here in this picture, if you focus on this triangle, triangle UTW, angle T is congruent to angle UWT. That's marked. So, in this triangle, because these two angles are congruent, the sides opposite these angles are congruent. That is, UT congruent to UW. Now, UW has a mark, so UT gets one mark. And that is by the converse. Converse to Isosceles triangle theorem. The converse states that if the two angles are congruent, then the two sides. So remember, it's the backwards way. And now you'll see that if UT is congruent to UW, it's also congruent to YX because they all have one marking. So in this space goes UW. So make sure you can explain these problems, okay? You might be able to understand why or what the answer is, but explain. Isosceles triangle theorem. Next one. The length of the base of an isosceles triangle is x. The length of a leg is 2x minus 5. The perimeter of the triangle is 20. Find x. So it's very important you can draw a picture. So here's a picture. This is an isosceles triangle, so the legs I'm going to put here and here. The base is in the third side, and it says the length of the base is x. One of the legs has a length of 2x minus 5, so I'll put it here. But the legs are congruent. So if this is 2x minus 5, so is this side. They're the same. They're equal. And now they give me this perimeter. Okay, this is a perimeter problem. The perimeter is 20. Well, to find the perimeter, you add up all the sides. So add up to x plus 2x minus 5 plus 2x minus 5. When you add all of those up, you should get the perimeter of 20. X plus 2x is 3x, and 2x is 5x. Minus 5 is minus 10. That equals 20. Let's add 10 to both sides. 5x equals 30, and let's divide by 5. And x is 6. Okay? And there's your value of x. So just be aware of the parts of an isosceles triangle. 3. One of these algebra problems here. So I have a picture. I have to find M and N. M is this little sliver of an angle. It's not the corner angle, it's a sliver. N is the corner angle, but of this smaller right triangle. So let's go ahead and start with N. If we look at this smaller right triangle, this is an isosceles triangle, so then the base angles here and N are congruent. So this up there is also N degrees. And now in this triangle, I have the three angles. The three angles are N, and 90. They should add up to 180. And I can find what N is. 2N plus 90 is 180. I will subtract 90 from both sides to get 2N is 90. And I'll divide by 2. And N is 45. And there's the value of N. So now I want to find the value of M. Well, M is just this sliver of an angle. The big triangle is also isosceles, so the corner angles are also congruent, and I'll use 2 markings for them. But what makes up the corner angle? It's M plus N. N is 45. M plus 45 is the corner angle of the large triangle. And again, they are congruent by the isosceles triangle theorem. So now in the big triangle, I do have the 3 angles, M plus 45 plus M plus 45 plus 50. Those 3 angles have to add up to 180. m plus m is 2m. 45 is 90, and 50 is 140. So I just combine my like terms. Subtract 140 from both sides. 2m is 40, and divide by 2. And m is 20. So make sure you're able to read the picture correctly. Don't assume, like in this case, don't assume m was that big entire angle. M was just the sliver. M and n made up the corner angles. Okay, and now we're going down proof row. Remember, there's so many proofs right on this test, so you got to be good. So here's a whole bunch, 3 coming at you. So we always start with the given, and in this problem, we are given that segment RS is congruent to TU. We're given that segment RS is perpendicular to ST. We're given that segment TU is perpendicular to UV. And we're given that T is the midpoint of segment RV. That's all given to me. Okay, so when I look at these givens, I see perpendicular, which means right angles. I am trying to prove triangles congruent, so I'm going to think HL. And again, the idea is there's only one pair of angles mentioned from the perpendicular lines, so there's no other angles. So I'm thinking HL is going to work, maybe. Okay, so let's mark what we have. RS is congruent to TU. Okay, so that's given to us. Segment RS is perpendicular to ST, so that's a right angle. And segment TU is perpendicular to segment UV. That's a right angle. So I'm going to believe that this is HL, so I will start by saying that these two angles are right angles. Angle RST and, not congruent, and angle TUV are right angles. And that is because perpendicular lines form right angles. So now, the given sides RS and TU, these are legs. They help make the right angle. So they are legs in those two right triangles. So now the question is, can I show that the hypotenuses are congruent? And we have not used this given. T is the midpoint of RV. Here's T, the midpoint. That means that RT and TV are congruent. The right angle boxes point towards the hypotenuses. These are the congruent hypotenuses. So RT, segment RT, is congruent to segment TV. That is again because T is the midpoint of RV. So that's by midpoint. And here are your hypotenuses. You have right angles, you have a hypotenuse and a leg, you have congruent triangles. Triangle RST congruent to triangle TUV. HL. So there's a typical HL proof. Again, hypotenuse to leg if they only give you right angles or perpendicular lines and no other angles. Okay, 5 here. Alright, so again, another proof. Let's start with our given. Segment LO bisects angle MLN. Segment OM is perpendicular to LM. And segment ON is perpendicular to segment LN. That was all given. And again, we're trying to prove triangles congruent here. Alright, so if you look at the given, they give us perpendicular, so I'm thinking maybe HL, but then look at the other given. Segment LO bisects angle MLN. They're giving us more angles, so I'm going to assume that this is not HL, because they gave us multiple angle pairs. Okay? Alright, so none of this is congruence, so let's say what we can say from it. Segment LO bisects MLN. So find where MLN is. MLN is down here. That means that these two angles are congruent. Angle MLO is congruent to angle MLO is congruent to NLO. And that is because of an angle bisector. And there's a pair of angles. Now, OM and LM are perpendicular, so that's a right angle. ON and LN are perpendicular, so that's a right angle. Now, I'm not going to say that they are I'm not going to say that they're right angles. I'm going to say that they're congruent. And I can use one letter. Angle M is congruent to angle N. You could use 3 if you want to. And this is because perpendicular lines form, and I just show that word congruent right angles. Because we know right angles are congruent, so if they form right angles, they have to be congruent. Okay? And there's another pair of angles. So again, this is why I'm not using HL, because I have 2 pairs of angles. So now I need a side. Well, look at how they touch, right? They share LO. Segment LO is congruent to segment LO. That's reflexive property. And now you have 2 congruent triangles, LMO and LNO, by angle, side. The 2 angles do not have a congruent side between them, so it is angle, side. Triangle LMO congruent to triangle LNO by angle, side congruence. So that's a tricky one where you think it should be HL because of the perpendicular, but it's really not. And lastly, number 6 here. Pretty complicated picture here. A lot of triangles going on, so maybe I'm thinking, hey, it might need 2 triangles. I don't know. Let's start with the given. Angle 1 congruent to angle 2. Angle 3 congruent to angle 4. That's given. So let me mark that. Angle 1 congruent to angle 2. Angle 3 congruent to angle 4. Now, if I look at triangle QET, QET does not contain both of those angles. Neither does QEU. So I'm thinking that QET, do my best here to trace, and QEU are going to be the second angles that we have to prove congruent. Alright? So what are the first? So I believe the first triangles we need to prove congruent, and I'll do it in red, are going to be QTB and QUB. So I'm going to first prove that triangle QTB is congruent to triangle QUB. That's the first thing. So that's where I'm looking to go. Well, what was I given? I was given 2 angles. An angle pair here, angle pair there. So now I'm looking for a pair of sides. Well, look at QB. It goes through the middle. QB is congruent to itself. And that's reflexive property. And that's a pair of sides. So now I believe the 2 red triangles that I have down here in orange, these are now congruent by the side is in between the 2 angles, angle, side, angle. Triangle QTB congruent to triangle QUB by angle, side, angle. And now we are focused on the blue triangles. If you look at the top 2, the top red and the top blue, we now need to find some overlapping parts from QTB, the red one, and QTE. Because we're going to use these overlapping parts to prove the blue triangle is congruent. Well, what is completely overlapping? Well, I see that QT overlaps in both the red and the blue. I'm going to use QT in this proof. The other thing that I see that overlaps completely is angle 3. Angle 3 is already marked congruent, though. It's up here. Okay? So we're going to use angle 3 and angle 4 in the blue triangles, and we're going to use QT and QU. Now, QT has not been told congruent to QU, so that's what we have to say. And this is by CPCTC from these 2 triangles above, right here, the ones we just proved. So this is a pair of sides. We're going to use this pair of angles. So I need one more thing. Well, in the 2 blue triangles, they share QE. QE is congruent to itself. Reflexive property. And that is another pair of sides. And now we look at the 2 blue triangles, QET and QEU, and we say, hey, side, angle, side, they're congruent. Triangle QET congruent to triangle QEU, side, angle, side. And there's your example of a proof with 2 triangles that you must prove congruent. Alright, I hope this video helps. Again, you should watch both videos for a very good comprehensive review, and I wish you luck on Friday and Monday. Alright, thanks for watching. We'll see you.